Alright, this should be another video for the scienceforums.net. I've gotten a few comments getting into kind of complex subjects, so I thought it better to make a video because typing all this complex stuff would be incredibly tedious. So anyway, this person, Maximal Deal, I haven't seen, I pointed out, I hadn't seen any radar, microwave, or radio slit experiments measuring received energy with an oscilloscope. Do you have a link? So he said, sure, and posted it. I should have posted it to begin with, sorry. And it's a link to the same old MIT experiments, and they're not measuring the signal of the microwave signal. They're not measuring the radar. They're just measuring the audio signal that's carried on the radar. So as I've pointed out for years now, putting this audio carrier signal just breaks the experiment in a sense, because then the experiment becomes what the audio is doing, and the experiment's not about what the microwaves are doing. And they're the real photons. The real photons are made out of the carrier, the signal carrier. Yes, the signal that's carrying the audio. So anyway, we'll play the end of this microwave experiment just to illustrate a point. So it's just typical. The only thing on the oscilloscope is the two, like here, in the middle here, they show just the oscilloscope's view. So we'll just play that. The only thing on the oscilloscope is the 1 kilohertz audio signal. So it doesn't have the radar signal on it. So when they say emitted wave, again, it's their jargon. And obviously it's a triangular wave, so the audio signal isn't even a sine wave, which makes it more susceptible to this amplification phenomenon. And then they have the received wave. These waves aren't emitted and received. They're both, one is placed on the transmitting signal, and the other one has to be amplified. I mean, it has to be pulled off of the carrier signal and then amplified. So they have nothing to do with the energy of the system. So you can see it's just a representation of the audio signal. So as the amplitude goes up, this is just a consequence of the fact that they're closer. They're getting the higher peak signal received because they're getting closer to the transmitters. So it has a higher amplitude, but really doesn't have anything to do with the real story. So this is where they block one of the signal, one of the antenna. So yes, it has an obvious appearance of something, but that's just the obvious appearance. Again, assuming is the thing you're not supposed to do here in science. So anyway, so no signal. He's going to block one of the antennas, and then you'll hear a signal. And clearly my argument would be he's at a location where they're a half phase out of sync. So the signal was being jammed, and by blocking one of the transmitters, he's now unjammed the signal, and now it's receiving a clear signal from the other antenna. So nothing miraculous. So let's see if there was something else I wanted to detail here. So again, the wires on this receiver, these are just the audio signal. First off, the antenna can only receive one band of microwaves or radar. So if it's either whatever it is, 8 gigahertz to 10, 11, whatever the number is, it's tuned to that specific frequency and can receive no other. So just understand that first. The same is true for the transmitters. They are diode controlled. They're not just plain antennas. They're antennas that already have transmitting circuitry built into them. This meter on the side of this one is also already converted. It's already seeking the audio signal, so it has the amplitude of the audio is being amplified in the circuitry of the device itself. So there's no separate device measuring frequencies. And so it's just feeding one line right into a speaker and feeding the other line right into the oscilloscope. Nothing to see here, really. It doesn't have anything to do with the carrier signal at all. It's not measuring the amount of microwave radiation hitting the antenna. It's only measuring whether there's an audio signal or no audio signal that's decipherable. And that's it. And we have more comments. Good, good, good. This video will be an hour long. So anyway, so I'll get back to the direct questions of this guy. All right. So in the experiment, it can be observed the audio volume decreases by 4 times. So if he had covered the speaker, so let's go back to the experiment. So if what he had done is placed the device, say, where there was no destructive interference, so where there was constructive interference, right in the middle, let's say, and then he had covered one of the transmitters, what would have been observed is that there would have been a 4-time decrease in the volume. So seems quite bizarre, right? You have 2 transmitters and yet your volume is going to go down 4 times when you take one of the transmitters out, and that's at constructive interference. So clearly the point I wish to assert here is that this is a phenomenon of amplifying a signal, a signal on a carrier wave. It has nothing to do with the fundamental experiment. The same thing would be true if my theory is correct. You'd have the same defects of amplification, or whatever you want to call them. It doesn't change anything for either theory. All right, so his response is, ideally an amplifier should give a linear relationship between power in and power out. Again, even just talking about an amplifier, we're already in trouble, right? Because that's a secondary circuit. You're not measuring the energy that's actually going from the transmitters to the receivers. Ideally, we just want to talk about the fact that there's a certain amount of wattage produced by the transmitters. The receiver is going to receive a certain amount of wattage of signal, and that's all we should really be trying to get to. And this idea of power in and power out has frankly nothing to do with it. A linear relationship means that the power in is doubled. Well, obviously we know the power in is going to be doubled because there's 2 transmitters. So that's the doubling of the power in. But all that means is now you're doubling the amplitude of the audio signal. So I'll attempt to draw this part. Then the power out is doubled. And if power in is 4x, there's no power in is 4x part, so I don't know where you got that from. Then power out is 4x and so on. Yeah, no, none of that happens in this experiment. Sorry. I contend, and I don't think, you know, I'm clearly contending that there's 2 transmitting dishes. They're just like light sources, 2 laser beams or 2 light bulbs, and the light's going to hit the other surface, and you're not going to get any interference pattern, just as you wouldn't get any with 2 light bulbs. You're just going to get twice as much light. Now, if you put a carrier signal, an audio signal on the light bulbs, that is, you blink the light bulbs, then that signal, when you receive it, will have the same phenomenon. You'll end up with a 4 times increase because of the waveform of the audio signal, not because of anything else. At higher power, the linear relationship deteriorates, but the problem is that the out-in curve grows less with the linear relationship, which means that you can't get quadruple the power out of a doubling of power in. Well, that's why I would argue that it's not really 4 times, it's really the pi argument is 3.1 times. But anyway, and so he goes to a Wikipedia article on gain compression, which again, this is all just stuff that happens in the amplifier. It doesn't really have anything to do with the base signal and whether the base signal is getting to the locations, whether the light is hitting those surfaces. Based on these points, I don't think you can say the audio has to do with amplification. Well, as you're just pointing out, gain is completely a phenomenon of amplification. So I don't know how you can separate the word gain compression from the word amplification. Although if anyone disagrees, please let me know. Well, I guess I disagree and I'm letting you know, but I probably don't count. As far as I know, for any wave, so again, says you. The intensity is related to the square of the amplitude. Obviously, the intensity has to do with the fact that when you draw, well, this is where I'll draw it. I might as well start now. So, sorry, this is it's going to take some time, so it's just the way it has to be, because it's just not as simple as people want it to be. Use my camera, yes, thank you. Wow, whoops, that probably has the wrong camera loaded, which I do. My bad there, sorry. Let's see, I have to make the window smaller, I guess, to be able to get to the features needed. There they are. My mistake. Get rid of all this mirroring crap, and get rid of the countdown crap, get rid of this flash crap, and use this camera instead, thank you. Come on, switch the camera. Please. Didn't switch the camera. Oh, come on. You can do it. Don't mess up this video. Oh, here. Okay, there. Now I fixed it. Whew. Alright. Sorry. I should have taken care of this ahead of time, but it does degrade the frame rate quite a bit, so I thought best not to get too far ahead of myself. Alright, we'll get rid of that. Alright. So problem is just how all these waves and all these frequencies are understood. So the first thing to be understood is the carrier frequency is literally 1 million times the frequency of the sound wave. So the carrier wave is, the frequency is literally 1 million times higher frequency than the audio signal that's placed on top of it. And the truth about these audio signals is that they don't really have, especially when they go into an amplifier, they don't have a plus and a minus to the curve. They just have a 0 to plus. So when they go into the amplifier, when the signal hits the antenna, okay, it's just in watts, number of photons. And the electrical signal produced, draw electricity like this or something, the electrical signal is produced in the antenna. It doesn't have a plus and minus component. It just has a plus component. It's just either a plus, it's a plus voltage. You don't have a plus and minus voltage. So there's no real sine wave plus minus through some kind of line. So you have to understand that the electrical signal is going to convert something that had a plus and minus component when it left into something that's only going to have a 0 to plus component when on arrival. So you have to really think that the real amplitude of the sound is the difference between these 2 points. So that's the amplitude, the real amplitude of the sound is from the negative point to the positive point. That's the real voltage difference. And so when you place the 2 signals on top of each other constructively, what you're really doing is just stacking 2 zero waves, 2 waves that, well, they're not waves, but anyway. And in a sense, you could just understand how, if I did draw it like this, if I literally drew it as a lump going up and a lump going down. Let's see if I can just do it with one. And I just put them like this, okay, where the bottom of this one reaches the top of that one. You could sort of understand how this distance, this total distance, isn't going to be the same as this distance and this distance added up. That essentially everything, this will be filled in by the amplifier. So the amplifier will fill in all the spaces that were that's essentially created by this doubling of the amplitude. And so it just really has to do with the fact that the amplifier has to recreate the plus and minus out of a plus signal. And so that's why it has this oh man, that's really not erasing very well. Whose fault is that, I wonder? I don't know why it's my little 10-cent whiteboard is not behaving. How outrageous. Anyway, so I would argue this is a phenomenon of amplification. Really doesn't have anything to do with the underlying argument. So I guess I could say I'll continue to argue if I must, but maybe you could agree that if I'm right and the signals are being jammed and there's still two on top of each other at the there's no argument that there's two signals going to the place where there's constructive interference. So we have the two signals, and then the two signals stacked on top of each other will cause the amplifier to make it a 4 times audio. The carrier signal will be amplified by 4 times just by the consequences of amplification. Now, if we could agree that that's true, then either theory would, let's say I was proven right in the future, okay, that somebody actually does the experiment where they attempt to detect the actual energy moving through space rather than an audio signal. There won't be a big surprise that, yes, both theories can explain why the amplification process distorts the amplitude of the audio signal. One would hope that we could agree. Okay, we're not on strange yet. Rather rude fellow. Anyway, so at higher power, okay, the linear relationships, we already did that. Based on these points, I don't think, okay, yeah, so I think we did, okay, this means that the amplitude doubles in constructive interference. The same is true for what I'm saying. It's not constructive interference, there's two signals. So two signals are received, they're in phase, it doubles the amplitude of the audio signal, and by doubling the amplitude of it when it's received by the antenna, the antenna is going to end up doubling it again. But the energy has to quadruple. Well, again, no energy ever quadruples. So, I mean, I'm not saying that you can't say this way. You can. Okay, I'm just saying that on its face, I'm just saying when somebody says the energy quadruples, that sounds like magic. Okay, because we know that energy into a system is energy out of a system, conservation, all that kind of stuff. So there can't be any quadrupling of the energy. We're just talking about what happens to an audio signal carried on another signal. And this really just has to do with a defect in amplification. It doesn't have anything to do with there being actually more energy. And that energy should come from the destructive interference. Well, again, not demonstrated. All right, so let's see who, well, I guess we'll just take them as they come. We apparently have some new rudenesses probably, but we'll see. All right, alternate reasoning, I stated. Radio signal jamming. Okay, I won't read my own comments. You would need to explain, one, why the higher frequency is produced. Well, I did that in the video, and I'll draw it for you. Where are these two windows? Oh, that's the experiment. Okay, so I'll draw it for you. So I already illustrated it the simple way, which is here's a frequency. Pretend there's lots of these. And then here's another frequency. And pretend there's lots of them. And all we're talking about is when there's destructive interference, we're just saying, oh, they slide over each other. And so the frequency goes from, let's say this is 1,000 hertz. This is 1,000 hertz. When they slide over each other, hey, guess what? It's 2,000 hertz. Yeah, the frequency doubled. Okay, so I can draw that if I must. Apparently I always must. So to put it in your jargon, it's a wave. And oh, this is not the best pen because it disappears. Okay, so we've got another one. All right, and so basically we're just saying that what happens when you put two of these waves on top of each other out of phase. Well, that means you put a hump here, you put a hump here, and you put a hump here. So what have you done? You know, you had this many humps before, and now you have this many. You have added these extras. So that's how the frequency is doubled. To make it really simple. Whether you look at it as a wave or you look at it as bullets at a frequency, you can understand that if I take two streams of bullets and I do them out of phase, that I if they were in phase, let's say there's no bullets, but I'm just saying when they're out of phase, obviously if there's 5 bullets and 5 bullets, then when they're combined, there's 10 bullets. It's not very challenging, I don't think, to understand. Why the higher frequency is produced? Well, that's why. And why a receiver tuned to that higher frequency does not detect the signal. So that's completely erroneous. Show me anywhere where they actually do that. See, if they would do that, then this conversation would be absolutely over. If there was one single experiment that actually tuned to the higher frequency that's created, then we wouldn't be having this conversation. But there is no such experiment, and that's the whole reason why I'm arguing there's been an assumption here, and they're just using experiments that are sort of engineered to prove the point they wish to prove, rather than an experiment to reveal what's actually happening. And the way to reveal what's actually happening is to do exactly that: tune the receiver to double the frequency, and if you receive a signal at double the frequency, that'll solve the problem, won't it? That'll tell you, oh, there is something there. All right. Interference is such a simple mathematical fact. So it's not simple at all. I mean, what can you even say to that? And to say it's a simple mathematical fact, no, it's a complex function. Water waves do it because little water molecules have adhesion to each other. So again, you're just walking into me saying, well, what, as simple as ether? So, I mean, what? Anyway, it's just so rude. That can be observed in water waves. Again, so, he's combining water waves, acoustic waves, and light waves. So we know that acoustic waves, it's because the atmosphere has pressure, it's under pressure. And so the molecules are forced into being tied to each other, to tension. We know that water has a tension because the molecules are actually attracted to each other and tied to each other, bound. So what's being bound in light waves? Right? You're ether, right? You won't say you're etherists, but you're clearly etherists. There's no medium for light waves. You haven't explained your medium for your light waves. Waves only happen in mediums. That seems a bit silly. So it's silly to recognize that water is really different than empty space. That's silly. Okay. To pretend it doesn't happen. So again, I'm not pretending that there isn't a phenomenon, that there isn't a pattern created. What I'm arguing is the pattern isn't created by what you think it is. As I've clearly pointed out in this video and in this argument, case 1, we're talking about whether or not actual different photons can interfere with each other, right? It's not one photon splitting into a wave function. These are different photons interfering with each other, which is a pretty anti-quantum mechanics in a way. And it's a pretty extraordinary claim you're making, because obviously I can't make photons interfere with each other in any other circumstance. I can't make light waves do that, right? In the sense I can't take 2 laser beams and make them bounce off of each other and interfere and create pattern, unless I put them through a mechanism that forces that to happen. Clearly in this experiment there is no slit. There is no compression of the wave. There is no there's no mechanism to create your ether disturbance or perturbations, whatever you want to call them. So again, I'm not saying the pattern doesn't happen. I'm saying clearly in this case the 2 signals are jamming each other, because the only way you can receive the signal is to be tuned to it. So whatever. All right. So then he says, normally we have physics crackpots coming up with their own crazy theories to explain these experiments. It's kind of the wrong attitude you have there, fella, but whatever. Now we have one saying the experiments don't exist. So that what am I supposed to say to that? Where did I say the experiments don't exist? I clearly articulated the experiments exist. I clearly stated the phenomenon exists. I'm saying your explanation of cause has no founding. It has no proof. You haven't proven cause. You haven't demonstrated with overwhelming evidence that this is the cause. Other causes can explain the phenomenon. And in this case of radar, the simple cause of recognizing that receivers cannot receive 2 signals at the same time. They are jammed. The simple argument is that radio receivers are easily jammed, and that would explain the phenomenon. All right, kudos for novelty, I suppose. It doesn't make you any less wrong. Well, pretending, you're a moderator and you're this rude. Okay, so yeah, calling yourself moderator doesn't make you any less rude. There, can I say that? Perhaps you are mistaking your ignorance. So he says, okay, no, I say the evidence is all NEEM interference is weak. So they won't concede the evidence is weak, that they don't have a great picture of this interference thing, that they don't show multiverses being created. So all of the professional physicists don't even agree on what physically is happening. Some say Copenhagen, some say many worlds, and then the third choice, which is some combination of the two. So even the physicists can't agree, and they won't concede that the evidence is weak. That weak evidence is why they can't agree. They can't concede that the reason why the physicists don't agree is because the evidence is weak. I mean, it's just so arrogant. There's no other words for that. I mean, it's just so bizarre that they can't concede that it would be good if they had better evidence. Perhaps you are mistaking your ignorance for the lack of evidence. Your ignorance of the evidence as lack of evidence. So however you demonstrate I have a lack of understanding of the experiments. I cited the experiments the guy showed. MIT experiments, didn't I? I said they made them in the 50s and 60s and in the 2000s. I said that, didn't I? I'm clearly aware of the experiments. So this is just character assassination. These are just ad hominem attacks. You don't have any substance here at all. You don't have. So the other guy was claiming. The other guy did the cliche thing. It was really rude. I should read his comments actually. The other moderator. He said Google says you're wrong because there apparently have been done single photon radar experiments, and I kind of just mocked that as saying, where's the evidence of this? Show me your link. There's no single photon radar experiments. It's preposterous. I didn't say all that, but I mean, obviously it's preposterous. So they just make these assertions because they don't want to care to understand the particular experiment that's being analyzed, and they just really couldn't care about details. And there are details. There are certain facts. Every experiment has a certain set of facts surrounding it, and they just don't care. They just throw them all in one clump and say it's all the same phenomenon. Light is water. No, it isn't. Given that it is, so I said, you have not demonstrated with any evidence, reasoning, or fact. So the guy said to me that I was wrong, and I said, no, you haven't demonstrated that with anything. Given that it is standard physics supported by centuries of research and evidence. So once again, it took 350 years ago, Newton discovered this phenomenon of interference. Young comes along and does nothing remarkable in the fact that he doesn't show us anything new. Newton had already done the experiment with single hairs, all that kind of stuff. And then 100 years after that, 130 years after that, physics decides it's going to decide that photons are waves. It decides to agree with Huygens. But in those 300 years, nothing. They had no theory. They had no explanation for the phenomenon at all. And then they come up with one in the 1930s, and we're still arguing about the interpretation. Again, 1/3 of the physics, they all have a different theory. And the theories are radically different. Copenhagen and many worlds are not the same theory in any way at all. And here he is saying that we already answered the question. You clearly haven't answered it very well. It's just so bizarre. Centuries of research and evidence. I'm not sure he needs to. So again, you don't have to use evidence, reasoning, or logic. You don't have to explain to me why it's impossible that it's jamming. You can just say it's not. And you're done. Because you've declared it's not. But you can't explain why it's not, or how that can't be the reasonable explanation for the phenomenon. All right, it's up to you, the one proposing a new theory. Well, what I'm proposing is I'm analyzing your theory. I'm not proposing a new theory beyond the fact that I'll argue why I can further demonstrate why this is not true, what you're doing. Okay, I have further evidence why you're wrong. I'm just trying to show you that your own experiments don't say what you say they say. So I'm analyzing your theory. I'm analyzing your evidence. That's why I called it weak evidence. It's because I'm showing you the weakness in your evidence. To provide the mathematics and evidence to support it. Again, I do not have to invent new mathematics. Mathematics is not a description of cause. Mathematics is a formalization of effects. We all see the effects. The effects are not in dispute. The fact that there's a pattern is not in dispute. The thing in dispute is what's causing the pattern. You have to separate causes, explanation of a cause, from explanation of an effect. The effects are not in dispute. Oh, amazing. All right. Then let's see. The power associated with the voltage is 4x. The transmitters produce watts of photons, I said. Perfectly sensible statement. The transmitters consume energy at voltage and current, a wattage. That's what's produced, like megawatts or gigawatts of energy goes into the antenna. All right, it's a wattage that comes out, like the light from a light bulb. Get more light, more wattage, more light. Are you suggesting that the receiving antenna can magnify that wattage? So that was to the other guy, just pointing out that there can't be any 4-time increase in energy. There's no increases in energy. So this guy says, it seems your knowledge of basic theory is severely lacking. So just an ad hominem bullshit statement. Where have I demonstrated some lack of understanding? I'm the one who understands that there's a diode inside the radio transmitters, okay? They're diode fixed. I understand lots of stuff that I bet you don't understand. Do you understand the relationship between voltage and energy? Do you understand the relationship doesn't mean anything because the wattage of the photons, the light being received, is being turned into an electrical signal, and it's not a plus and minus electrical signal. It's a ground to plus signal. It doesn't have bipolarity, and it's going to be converted, and it's through that conversion process that the signal's amplitude changes. Are between amplitude and energy. So again, these are all things that have to do with amplifiers. They have nothing to do with what happens from going from point A to point B, from transmitter to receiver. Do you even know how the wave equations you are discussing? It's not a wave equation. So do you even know the wave equation you are discussing? I'm not discussing a wave equation. I'm discussing jamming and whether it's a real phenomenon or not a real phenomenon, and whether it explains the effects in the radar experiment. That's what I'm contending. All right, the wave equation, as you've described it, again, doesn't have a wave in it anywhere. There's no wave in the wave equation. There's sine theta. There's an angle. It's an angle equation. That means force is deflected at an angle. It doesn't necessarily mean there's any such thing as a wave anywhere. Oh, here he is. Snot, or something like that. Swan knot. Swan snot. I mean, just the bizarre icons. He says right on his own, this is a moderator, and he has the subtitle "Evil Liar," or so I'm told. Now maybe they just do this in this message board just to be even more obnoxious than necessary. You know, he doesn't really pick that title. But these are moderators. So they think at this message board that it's constructive to conversation to title yourself "Evil Liar." Yeah, no, I don't think it is. Okay, so here's what I said. You said the evidence for single photon interference is weak. Yes, I contend that it's incredibly weak. The very fact that your own professional physicist can't decipher it into any kind of direction. They don't know which direction to go in. Feynman says randomness is at the core of the universe. Okay, he doesn't even believe that photons are waves. Okay, and you know, the others will be doing Copenhagen, and then they'll create this idea that there's many worlds. Do you think that means you have strong evidence when your physicists can't agree on a cause? Okay, no, I say the evidence. Okay, so here's the first sentence of your first post. No, the first sentence was of the direct commentary was case number 1. So we're talking about radar. But anyway, I would argue the evidence that photons interfere with each other or themselves is extremely weak. Yes, it's exactly what I'm saying. You don't understand that, huh? I mean, you've now written it twice. I said it, yes. I asserted it. That's what you're quoting me saying. But if you want to explain that to all interference, expand that to all interference, fine. Again, yes, that will be this is case 1. We're talking about this one experiment. See, you people want to turn all the experiments into the same. Water's the same as glue, is the same as horse poo, is the same as whatever, duck piss. No, they're not all the same. They're all different experiments. And if you clump them all together and pretend they're all created by, look, the photons created by a radio transmitter, unlike light, they're all in phase. Every single one of them is in phase. So every ray of force, so to speak, every whatever, a wavicle, whatever you want to call it, every single one of them is in phase, where light isn't produced that way, right? It's very, very difficult for us to force light to be in phase. We have to use complex lasers, try to reflect the light back and forth, create some resonant frequencies, but we can never get rid of the harmonics. We can't get rid of the fact that the light is going to be produced out of phase in little point sources. And this is a problem for LIGO. They try to get their beam as in phase as possible. That's the only thing they care about. And it's just not that easy. So they're fundamentally different carriers, aren't they? Isn't photons that we see, they're fundamentally created by a different mechanism. Radio, antenna jiggling is different than burning a filament. All right. But if you want to expand that to all interference, fine. Yes, that's what I'll be doing eventually. One experiment at a time. How do diffraction gradients work? So again, he's just changing the subject. I mean, I labeled it case number 1. It's right there in my post. Case number 1. I'm talking about this particular experiment. I said it to him in the comments. I'm talking about this particular single experiment. And he keeps wanting to change the subject. How do thin film interference work? Well, I'm going to get to that because I'm going to argue that your interferometer is complete nonsense. The idea that you can have a half-silvered mirror and the half-silvering doesn't create a bunch of tiny little slits, and the tiny slits are going to diffract the light. Of course they're going to do that. Yeah, I'll get to that. I'm on this subject first. Anyway. And you don't get to move the goalpost. So, I'll read my statement here. No, I rationally chose to discuss the very different experiments individually, as they have very likely different causes and effects. As I'm pointing out, water isn't light. You don't just talk about them all like they're the same thing. It's not smart to do that. It's your claim. It's wrong. You have not demonstrated that with any evidence, reasoning, or logic. So again, this is a moderator who says things like, it's your claim, it's wrong. When you say something like, no, I rationally choose to discuss one experiment at a time because I understand the experiments are fundamentally different. They're physically different. As I pointed out, see, if you do this with like megahertz or regular radio, AM radio, you don't have the same problem with the fact that the transmitting and receiving antennas are diode controlled. So you don't have this problem where they can't receive other frequencies. So you have some hope of tuning into the higher frequency, but you have to do it. You have to deliberately tune into the higher frequency. But you have some chance. But the problem is you have to do it in a much larger space because the interference, you need 40 or 50 meters of space. So you have to do it over a much larger distance. And you have to violate FCC rules and all that kind of crap. All right, you are the one making the claims here. The burden of proof is on you. There's no burden of proof here. I'm arguing about the conclusions drawn on an experiment, a specific experiment. What burden of proof do I have to argue that how does jamming not explain the phenomenon? How if jamming was true, if the signal's being jammed, as it is, if it is true that the transmitter can't receive a double frequency, how is it not true that you would get exactly these results if it was just the signal being jammed? You would have the experiment would look exactly the same if jamming was the explanation. You're the one that needs to demonstrate how there's something unique in this phenomenon that proves that jamming can't be the explanation. Go do your homework. When you did your homework, were you instructed that jamming is the same as interference? Let's see what he says. The claim that jamming is not interference does not support the notion that interference itself doesn't happen. Again, I'm not proving that interference doesn't happen. I'm proving that this experiment doesn't prove it because it doesn't show any uniqueness. There's other explanations for the effect. So if you're going to claim a specific cause, part of your responsibility to say this is really good evidence is to point out how no other theory works. That's part of the argument you make. You can't just say, well, that sort of says it. I mean, that's one of the burdens of evidence. Evidence doesn't mean like you have one piece of evidence and you go into court and you say he's guilty, and that's all I have is one piece. It requires it to be cooperative, and there has to be some exclusivity to it. You know what I'm saying? I mean, if I have the same genetic, look, he has the same genetic code as 1 million people out of 300 million, so therefore he must be guilty. Well, you haven't narrowed it enough to say I'm guilty. All you've done is shown, oh, look, it's similar. It looks like. You haven't shown that it is like. All right. It's like claiming color red doesn't exist by pointing to a single blue object. No, that's exactly what you're doing. You're saying I don't have any responsibility to demonstrate how this evidence is exclusive, how nothing else can work as an explanation for this experiment. The experiment only has one solid pointing vector as a fact. The evidence, this experiment points to one fact and one fact only. It doesn't do that. Okay. Where the two signals are out of phase, the signals are superimposed and the resulting combined higher frequency is not the one the receiver is tuned to receive. Well, that's just too obvious. Okay. The addition of two sine waves of the same frequency only gives a sine wave of the same frequency. That is the most ludicrous thing I've ever heard. Two out of phase sine waves do not give you. I shouldn't have to draw that, right? I mean, he's basically saying that, okay, this plus this. I mean, he doesn't know what destructive interference is. The whole idea is they're out of phase. That's the destructive part, is when they're out of phase. Yes, when they're in phase, it's the same frequency. But obviously when they're out of phase, it's not the same frequency. Obviously. All right. There is no combined higher frequency. Well, I would assert that is incorrect. Completely incorrect. Insanely incorrect. So, you know, really, really, really incorrect. How about that? Also, so this guy's called an expert. Amazing. Also, if the combination gives rise to the wrong frequency for the receiver, how come you ever get the signal? Ever get the signal? Well, you get the signal when you're putting the same frequency on top of the in phase. When they're in phase, you're creating more energy that the receiver can receive. When they're out of phase, the receiver says, wrong frequency, I can't do anything with that. Twice the frequency. So go ahead, try to get 101 FM. Try to hear 202 FM when you're tuned to 101 FM and see if your radio will do that. See if your radio will let you hear 202 FM when you're listening to 101 FM. Try that experiment. Sorry, I'm being patronizing, but this is a brood. You know. All right. Also, if the combination gives rise to the wrong frequency, yeah, sorry, I just did that. And how do you explain the fact that the pattern of peaks and troughs, whatever, on and off, both in position and intensity, exactly match that expected for interference? It's an on-off pattern. at precisely multiples of an angle. So you multiply the angle, 3 degrees, 6 degrees, 9 degrees, 12 degrees. Simplest pattern you can call a pattern. There's nothing that you can't make a pattern any simpler than this. All right, so you're saying, I know that anytime on-off shows up, it's interference. No, that's not true. It's caused by some other effect. I'm obviously arguing that the pattern, okay, the jamming would have exactly the same distance relationships. I mean, you know, let's understand that we're not disagreeing about the physical phenomenon here, right? We shouldn't be disagreeing that there's two antennas, okay, and that when I'm over here, okay, I'm closer to this antenna than I am this antenna, all right? And if these are bullets coming out of the gun, we'd have exactly the same, oh, the bullets are in phase or the bullets are out of phase phenomenon. It wouldn't change the fact that there's a frequency and the frequency has a different distance. We're not arguing that. We're not arguing the phenomenon of frequency and phase. Those are real things. What we're arguing is whether anything interferes in here, whether these are two waves that are interfering with each other and no energy gets to certain locations. That's what's being argued. And I'm arguing that no, the energy's there, and all you have is a broken frequency. You're not tuned to the frequency that's at that location because you have two out of phase frequencies. Oh, still another one. Wow. Very popular all of a sudden. Never mind. Oh, that's not too good. This does not show what I claimed because the signal is amplified to the maximum whether or not he is blocking one of the transmitters. This is a bad link. Oh, cool. Consider this. Okay, I will later. When he removes the antenna, the signal, this time shown in terms of current, drops by 2. But not quite exactly though. Well, again, he's not measuring the radar signal. He's measuring the receiver. The receiver has to receive the signal. So he's not measuring the energy at the location. He's measuring a frequency at a location. All of my arguments still stand though, so they shouldn't be dismissed. I wasn't dismissing you. You're quite a decent fellow. I'd be interested if someone tried to do the MIT demo, but with the purpose to read the voltages accurately. Well, to read the voltage on a real antenna. So all I have to take is a metal... See, the point is if you use microwaves, you have to use enough intensity so you can pick up the actual light of the microwave. So it's an experiment that has to be done remotely. Like you set up the experiment and then you have strings or something you can pull so you can stand 20 feet away or whatever, but you don't want to get irradiated. But yes, ideally you want to pick up you want to do the receiving with just a little piece of metal and just receive the energy. And then if you do that, you'll see that when the dishes are on, you have an energy signal. And you'll see that the signal does not have any interference pattern. The energy will always be consistent. Okay. I'd be, yes. Yes, it'd be nice if they did this experiment without the gimmick of the audio signal, the carried audio, and then accurately compare them with one transmitter is blocked versus when it is unblocked. Well, I mean, all you're going to find out is that you have two transmitters, and all there is going to be when you have one unblocked is half the signal. When you block the other one, you got half the signal. That's all that's really happening to the radar signal. It's only being cut in half. It's that half means 4 times in amplification. So once it gets to the amplifier, that half becomes a 4. Alright, all my arguments still stand though, so they shouldn't be dismissed. So now this strange guy's going to argue with the other guy again. Your idea can be trivially dismissed because the mathematics of waves show that it is wrong. So he's arguing now with the other guy. Who amazing. They can also be trivially dismissed because observations and experiments are consistent with the mathematics. So this is just such an evasion of the subject. The point is that this is taught as a demonstration of interference, and there is an alternative explanation that is quite logical and obvious, and it's called signal jamming. It's a real phenomenon, and you haven't in any way shown how it can't be the explanation for the consequences, for the effect. You also need to provide better arguments than videos. So he's arguing with the other guy as if I said this. I didn't say what he quoted. This isn't my statement. So he's arguing with somebody else's statement and thinking it's mine. And he's a moderator. You also need to provide better arguments than videos. All right, so I don't understand why. So colleges really shouldn't do lectures. Right? The professors don't need to do lectures. They just need to write a book, give it to the students, say hell with it. Because there's none of these things are complicated enough to require somebody to actually explain quite a bit of stuff or to even draw a picture. I certainly won't watch them. So, okay, then you're not going to engage in the conversation then. Yes, sorry, it's one of the liabilities of the conversation. So if you can't do that and you're not willing to do that, yeah, then please just do something else. You know, find something else to argue. Maybe there are people who are willing to understand that the subject is a little bit complicated, and you know, you're not going to be able to just do your triviality thing. All right, amazing. You need to provide your mathematical model. Again, I'm not disputing any mathematics. There's no mathematics in jeopardy here. I accept the angle equation as being generally a good approximation of the reality. We're talking about causes. You want to say I'm changing the effects. I'm not changing any effects here. I'm not disputing the outcome of any experiment here. I'm disputing an explanation of the cause. Oh man, you need to provide mathematical for some evidence to support your claims. Again, what do I have to support? Evidence of the existence of jamming as a phenomenon. So you need me to explain to you how jamming is a real thing that happens in the real world. Your idea can be trivially dismissed. Okay, so he says, oh, so the Max Emil Deal guy was saying, I think you're confusing me with draft physics. I am arguing why draft physics is wrong based off the fact that the intensity is proportional to the square of the amplitude of the wave. If this is not true, please tell me. Yes, I'll tell you what you're saying is not true. It's entirely something that happens in an amplifier. It has nothing to do with what happens to the energy being transmitted from antenna A to antenna B. None of this is true for that. The energy transmitted from the antenna to the antenna, there is no 4 times the energy thing. There's no such thing happening. It just has to, this is just this doubling, and I mean the quadrupling thing just has to do with a glitch of taking an on-off electrical signal and turning it into a sine wave. It really just, I think, fundamentally, it just has to do with sine waves are circles, right? So, and if you increase the diameter of a circle, you 3 times the circumference kind of thing. So I don't think it's really 4. I think it's 3.14. Okay, because that's all it really has to do with. It just has to do with when you double the amplitude of a circle, you double the diameter of a circle, you're going to, or radius in this case, you're going to get a 4-time increase, if it was a sphere, in the circumference, the surface area, the area. All right, so, sorry, very long video, but I really don't think there's any other way to do this in terms of, you know, attempting to type responses. I can always take the transcript from this video and attempt to place it in here, so we'll see how that goes, and such. I don't need to do this, whatever I'm doing here. That won't turn the recording off. Shortcuts, that's right. Alright, so thank you very much. Thanks for your patience. Thanks for listening if you did, and I appreciate it.